Hello to everyone, and welcome to our first lecture in Math 143. As it's still early and everyone's getting used to things, perhaps I just want to check that everyone can both see and hear me. Everything looks good on your end. Right. No one seems to be watching in YouTube. Perfectly fine. But if they are, then they will hopefully tell me whether or not things are looking good. Okay. Now, we are slowly easing into things. Sometimes perhaps a little too slow for some, but it's better to just get used to things and try and shake those Christmas break cobwebs. Our introduction will be on the topic patterns and sequences. And when we look at the worksheets and think about what level we might be teaching and introducing patterns and sequences, it's often done by way of pictures, different diagrams, trying to illustrate and get kids used to noticing patterns and trying to exploit a pattern to predict the next shape in the sequence. So let me just get something to write on. And we have our first exercise, exercise 1.1. So the first issue is, do we notice a pattern in the shapes? And can we use that to predict what might come up if that pattern continues, what might come next? Let's get used to writing some stuff here. Our first exercise, 1.1. My pen is a little thick. That's way too big, huh? I'm looking size a little smaller. Maybe like that. That's good. Yeah, that should be fine. Okay. So we have the first one here. So we see they're all squares and the diagonal line is alternating this way, that way, this way, that way, this way, that way. So this way should come next. Very simple, nice little introduction for your very first exercise. Then we have little rectangles here. Let me just see if that looks big enough. Enough. Little rectangles, and the lines are changing. Are they changing in a consistent way that helps us to predict the next one? Vertical line, horizontal, vertical line, diagonal, vertical line, horizontal, vertical line, diagonal. It's like a song. Vertical line. So next would be horizontal. Now, it's deceptive when you introduce this for the very first time. Not all kids uh, notice things that you might think should be straightforward. Everyone's different. Really can't predict. And you have to be patient sometimes. Number 3, we have some polygons here. Now we'll talk about polygons in the second half. But you see the number of sides decrease systematically. This is a hexagon here, 6 sides, 5 sides, 4 sides. So if that continues, the next shape will have 3 and therefore be a triangle. So it's important that I investigate if I see a pattern And then I have to be able to explain what pattern do I see and how do I justify my prediction for what is behind the question mark. Maybe this one's a little bit more complicated compared to the rest. Number 4, we have some sort of rectangle with curved corners, and then a smaller version shaded in. Then we have some sort of oval here with a circle, sort of its smaller version shaded in. Rectangle with a square as its smaller version shaded in, and then a triangle, so it'll have its corresponding little version, equilateral triangle, shaded in. Try and make an equilateral triangle, doesn't have to be perfect, shaded in. Now, admittedly, this is just our introduction. It's a good place to start with kids, definitely, because it's nice and visual. They respond better to shapes. But the idea of noticing a pattern, explaining that pattern that we've just done verbally, and using that to continue the sequence is the fundamental aspect behind this topic. Now, we can't really go very far with shapes involving patterns, and my drawing skills will show their weakness very quickly. So we're going to switch to sequence of numbers, but the underlying issues are the same. Can we see a pattern? Can we explain that pattern? And can we use that to predict the next number in the sequence? Now I'm just going to move my book to my other screen instead of back and forth, but I'll still write the questions here, write the sequences that we have, so you won't be missing anything. For bigger questions, it's nice to show the page on the screen, but these are quite straightforward and easy to copy. So the very first one, we have 1, 4, 7, 10, 13. Now maybe you immediately say, just sort of automatically out of habit, what the next one is. But it's very important to think of it from a teaching point of view as well. Whoever is your audience, they might not see things as quickly or easily as you. You always have to be ready to explain it in that situation. So, first of all, do we see a pattern? And what is that pattern? Just in words, what do we notice? What is the pattern that we see helping us go from one number to the next? Now, we get, even in this simple-ish topic, we get much more out of it if we have a conversation, if it's a discussion. I've said some stuff, I've asked the question, what pattern do you see? Then you say stuff. Every time it increases by 3. So let's write it down for this first one. And you can use whatever words you want. Increases by 3 each time. Okay? Our introduction doesn't have to be super fancy. And that allows us to then say, oh, so the next one should be 16. Simple as that. And with each sequence that we see or discuss, our experience increases. We gain experience, which allows us to maybe handle more complicated sequences systematically. Right now I see, oh, I could add numbers every time. 1, 4, 8, 13, 19. Let me just turn the light on. It's so dark in here. So any difference? Difference for me. First of all, before I draw the square, do I see a pattern? And can I explain that pattern that I see? Because that's my justification for my prediction in the next number. So we've learned now that, oh, okay, I can add numbers to go from one to the next. So it's good to then check, does it work in this case too? Well, here I'm going to add 3 if I want to go from 1 to 4. Then I'll have to add 4 to go from 4 to 8. Then I'll have to add 5, and then I'll have to add 6. Now it's not the same as the previous one in that I didn't add the same number every time, but there is still a pattern in what I'm adding. So I have different levels here. I have the original sequence at my main level, but if I go one level down to see the numbers added in this case, that itself might have a pattern that is maybe easier than the top level. And in this case, the numbers I add increase by 1. So the next number I add may be 7, and that allows me to make a prediction that most likely the next number in the sequence is 26. And I can explain that and defend why I say it's 26. I have limited examples. I have 5 numbers to make a prediction. Sometimes that's enough to be fairly confident in my prediction. Sometimes it's not. If you have done 142, it's not essential. But if you have, you'll remember inductive reasoning. There is a little bit of a risk to having very limited examples and then making a confident conclusion from that. I'm sort of at the mercy of what I see. And sometimes it might not be enough. And the sequence could actually be much more complicated than I think. But for our introduction, it's good to know those things might be out there, but we try and keep things fairly contained. Only now and then, just remembering things can be much more complicated than we're going to mainly do. Next sequence, 1, 2, 4, 8, 16. Let's up a little bit here on the page. So now I've seen, okay, I can add numbers every time. This one doesn't seem to necessarily work in exactly the same way by adding. What else can I do? What other pattern could there be? That was a question, which means it'd be nice if you answer. It can also be multiplication. Why not? So I'd be, oops, I'm in eraser mode here. I could multiply from one to the next. And in this case, I'm not sure why I'm writing so small. They're all squished together here. In this case, I'd be multiplying by 2. Let me see. My writing is unnecessarily small. That's okay. We can still see it. And then, now this is enough for an explanation right now. Just know that by saying it or helping write a few arrows underneath, we are explaining the pattern that we see, exploit to make a prediction for the next number. So by now I've realized, oh, I can use any sort of arithmetic to link one number in the sequence to another. Could be addition and therefore also subtraction. It could be multiplication and therefore also division. Let's see what else we have here. Number 4, we have 10, then 100, then 1,000. Like a little comma there. Then 10,000, and then my next one. Now, building my experience should allow me to very quickly realize, oh, this is multiplication by 10 every time. And the next one is easy to justify why I think it should be 100,000. Right. Now, I'm just going to do things in a slightly different order. Actually, no, I like number 5 next. Number 5 is good. Build things up in the nicest way possible. So with every example, we gain some experience, which makes future examples easier, in theory. You can say here, okay, well, we have adding numbers, adding, subtracting, multiplying, dividing as options. And now I can run through the options. Ooh, what do I see here? Let's try adding. I can add 3. I can then add 5. I can then add 7. And those numbers don't have to be the same, but there is a clear pattern among them that I'm adding by increasing odd numbers. So the next one I'll add is 11, and then the result or the prediction with confidence, fair bit of confidence in this one, is 36. So here we have one way. Let's say we add increasing odd numbers. Now we could be more elaborate and detailed in our words here, but just having some explanation, right? This is one way to do it. But there's also another way. Nothing wrong with this way, but it's not the only way. If I just give my sequence some places here, and this number 1, 4, 9, those are the numbers in the sequence. It's not going to change, and I'm looking for the next one. This number 1 is in the first position. So I have the sequence itself here, and I'll write underneath the positions in which those numbers occur. And I'm going to do it in brackets so I don't confuse myself with which one's the sequence and which one is the position numbers. So this is position 1, this is position 2, this is position 3, 4, 5, and I'm looking for 6 ultimately. So I have two options. In the first one that we finished, I went from the starting number to the next one, then to the next one, systematically working my way to the box, to the square. Alternatively, I could try and find a connection between the number and the position that it's in. Is there a link between this number and its position, this number and its position, this number and its position, and so on? It's a different way of looking at it, but still at the same sequence. Can we see a link between those? Well, at this stage, we don't need to prioritize one above the other. It's just another way of looking at it, which down the line may or may not be more convenient. So the position value times itself gives me the number. So we can write many words here. Let's just say informally here, the position squared. We can elaborate on this, but there's no need. We've said a lot of it in words. And that then allows me to make a prediction for the number in position 6, 6 times 6. And I get the same thing. It's the same sequence, just different ways to describe and look at the exact same thing. Exact same thing. While I'm thinking of this, the numbers in the sequence we call the terms of the sequence, because they might not always be numbers. They might be other things. We call them the terms in the sequence, because position values also are numbers, right? So a lot of numbers floating around. So people decided long ago, let's give this a different name so we know when we refer to objects in the sequence versus maybe other numbers floating around. Okay, so to get the term in position whatever, I take that position value and multiply it or square that position value. Okay, good. So we'll keep this in mind, and it'll come up a little bit later. I just want to look at some other sequences, the other ones we have in our exercise 1.2. I'll do number 7 next. 11, 23, 35, 47, 59. Of course, there are so many more examples I could have, right? Just, oops, just trying to illustrate basic things we should see in one form or another. Just because these numbers are bigger doesn't change how I look for patterns initially. And I see, oh, well, I can add by 12 here. I can add 12 and I can keep adding 12 and every time it works. So I'm back to the first way of sort of doing it sequentially. But if it works and I don't have to do more with it, why change things, right? Go with what works. Uh, so we have 59 plus 12 is 71, and I'm done. Perfect. No problem at all. I know that there are other ways to look at things, but if I don't need such a fancy view for my goals, why bother? It'll come up later. Then we still have to do number 8 I'll do next. We have 1, 6, 4, 2, 0, and it continues forever. This one just obviously looks different because some numbers go up and then go down again. And with these last two examples, I just want to show you, we do get conditioned, and I think school does that as well, that every question has an answer, and I have to find the answer. Sometimes things are different. I don't see a pattern. That doesn't mean there isn't one. That just means based on my experience that I have so far, which is quite limited, we've only done a few examples. We can't expect to notice every pattern that's possible, right? And that's not any reflection on me. It just this topic of noticing patterns in sequences. There's no end to the complexity. And I'm at the mercy of my experience. This one, based on what we've seen so far, a little different. Don't know what to do with this. Maybe I don't see anything. I'll give you a clue. It's my first clue, which might not be enough. And as I enhance my clue, maybe something comes to mind. Let me know when something happens in your mind. Not that it has to. These last two examples, I'm not going to make them test questions, but it's important to see that there are many other patterns out there that I might not have the experience to handle at this stage, and that's okay. That's not a bad thing. It's just a very big topic. We try and contain it, but don't for a second think that's all there is. So it's nice to see other things like, whoa, okay, I don't want to play with this right now, but it's good to know they're out there. Does anyone have an idea what this pattern is? I am just adding in a loop on a circle. So I've mixed a couple of elements here, still adding, but there are different ways to add. Again, this is just for interest's sake. Don't worry about this, but it's important to know that there is more than just what we're doing. We might not be ready for it, but that doesn't mean it's not out there. So then 0 plus 5 is obviously just 5. So 5 steps, 1, 2, 3, 4, 5 gets me to 6. 5 steps, 1, 2, 3, 4, 5 gets me to 4. 1, 2, 3, 4, 5 gets me to 2. 1, 2, 3, 4, 5 gets me to 0. And then, of course, 5. So there are interesting things, but of course, we have to do things systematically, right? It's such a big topic, we can't do everything at once. But it's good to just have it in the back of your mind that, oh, there's much more that we could do. I'll change, not number 9. That's not at all what I wanted to write. I think we skipped 6, but I am going to change 6 because there is a little bit of a typo. 3, 1, 4, 1, 5, 9. Oops, I'm sort of encroaching here. There's my sequence. We have to be okay, just in general. If you go out there and look at sequences, it's not a test question or anything. I don't know what we're going to get, right? Sometimes it's just a matter of I do not see any pattern. And sometimes it could just be a list of random numbers. I don't know. And that's okay. Now, I'm not going to give you a test question like that, so don't worry about things like that. But no, that sometimes I just don't see anything. That doesn't mean there isn't anything. Based on my experience, where I'm at right now, it's too much for me. Like this, I have no idea what the next number is. Don't see anything. I can try adding, multiplying doesn't work. I thought maybe the ones alternate. 3, 4, 5. It just doesn't work. Now, the more I see, the better it might get. But there is no pattern here. This is actually the digits of pi. And pi is probably one of the most well-known numbers to be a non-repeating, non-terminating decimal. It has infinitely many decimals, infinitely many digits that never repeat, that never has a pattern. It's not completely random either. It's something in the middle. So we don't have to think that, oh, we have our introduction of sequences and now we can do everything. No, not at all. Not at all. There is a bunch more that there's no end to the difficulty. So we definitely want to contain things. Otherwise, it's going to get overwhelming. Let's go back to the sequence 1, 4, 7, 10, 13. That keeps going forever. Let's go back to that. That made me feel much better. It's nice to see things, add some experience, but maybe it's too much variation right now. Let's stick to something that I hope most of us saw a pattern fairly quickly, that we're adding 3 every time, and there is nothing wrong with that. So in words, I could explain this pattern. But what I have to say in order to clearly explain this specific sequence, it's not just one thing. I can't just say add 3 every time. Let's imagine you're going to your friend and you tell them, I'm thinking of a sequence of numbers. I add 3 every time. Is that enough information for them to write down the sequence? Just knowing that you add 3 every time. Not enough. Not enough. Because they need to know where to start in order to get things going. I could start at 2. Then I get 2, 5, 8 in a different sequence. But I'm still adding 3 every time. So there are 2 things that I need to know. I need, or tell my friend, I need to start at 1 and then I need to add 3 every time. Now, when we use words, it's fairly casual, meaning every time meaning going from one to the next. We can elaborate on this last sentence, right? Saying that in order to get a number in the sequence, I have to take the previous one and add 3. So we can be more specific here if we want to. Let's say it like this. To get a term, those are the numbers, the terms in the sequence, add 3 to the previous term. That'll be more specific. To get the 7, I take the previous term and I add 3. And once I have the 7, I can get the next one by looking at the previous one and adding 3 and so on. Okay. But because we're working with numbers and something that's can be a little bit technical, doing things in words all the time is going to limit us. It can be a little confusing and hard to find the right words to say things exactly right in a clear way. And the English language isn't the ideal language in which to analyze technical things, do calculations and things like that. So we want to work within the mathematical language. Now, I could say in English here, right? Start at 1, add 3 every time. If you understand the English language, you would know what to do. Someone else could translate this and say it in French. If you don't understand French, then it will be extremely strange and you won't know what to do. This is just another language. And to understand how to read and say things in this language, we have to understand the words that we're going to use. So we're going to say the same thing, these two things, in this language, but first we have to understand how the words are going to sound in this language. So let's just say some things in general. I have my sequence. Now I don't know what it's going to be, but the first one is going to be in position 1, position 2, only one position 2, position 3, position 4, 5, and so on going forever. So I have my sequence here of terms in the sequence, and then I have my list of positions underneath that I put in brackets so I can tell them apart. Okay. Now I don't know what specific sequence I may want to look at, so I want to give them general names, knowing that there are numbers and I might have a specific sequence like this one that I want to look at, but I don't want to restrict myself to look at a specific example. So I'm going to use letters to indicate the name of the term in that position. Now I could use A, B, C, D, E, and so on, but if I have more than 26 uh, terms in the sequence, then I'm going to run into trouble and it's just going to get messy perhaps. So I want to use an A for every one of them. But of course they're not the same. I can't do that. So I want to let the position help me give this a unique name and use the subscript, the position value as a subscript. Now A1 is the name of the term in position 1 of the sequence. A2 is the name of the term in position 2. And now they all have different names, and I really will never run out of names because I just change the subscript. It's just more efficient. Not the only way, of course, but this is sort of a standard way of doing it. Okay. So without knowing exactly the sequence I'm looking at, I'll just use these names if I need to reference some of them. And of course, these positions continue forever, right? If I want any other position, you might pick position 70, or someone might pick position 100. There are all kinds in here. In general, without knowing what position I want to look at, I'll leave the position sort of flexible as well and use an N for whatever position you may want to look at. Then the name of the term in that position is an A with the corresponding subscript. Okay. So in order to read the language, write in the language, we have to understand the basics of the language. Of course, that makes sense for any language. This is no different. It's a language with its own words, its own grammar, its own rules for how to work within that language. But when it comes to technical things, the mathematical language is just way more effective than the others. All right. So now I want to say the exact same thing to explain this sequence, but in the mathematical language. Note that I am not going to say anything new, anything different. It will be these 2 points that I'm translating. First point says start the sequence with the number 1. So now I want to say in the mathematical language, the first term should be 1. First term is named A1. That should be equal to 1. Now, it's just a coincidence that position 1 has the number 1, right? There's a difference between the number in the sequence, the term, and the position, right? In this case, they just happen to both be 1. It's a fairly simple sequence. I could have started somewhere else. So this is exactly the same, just translated, same information. And once I see math, especially in this topic, once I see it as a language, just a translation of things I could say in words, then it's not scary or threatening at all. Because I could say it in any language. I just need to learn the language and then I'll understand everything. All right, so now how do I translate this in the bracket? It's a little bit more specific, right? Yeah, I could say casually add 3 every time, but the bracket is a little bit more specific in what I need to do. To get a term, wherever it may be, I have to add 3 to the previous term. Okay, so I'm not specifically saying which term I want. To get the next one, so here's the second position, right? This one is named A1. I have a specific number for it, but in general, they always have these names if I need to refer to them in their general name. So in order for me to calculate or to find A2, the second term in the sequence, what does this say in the bracket? Add 3 to the previous term, which is A1. Is everyone happy with that? It's very quiet. I don't like when it's so quiet. It makes me uncomfortable. Everyone's still keeping up with things. All right. So now, the problem is that's perfectly fine, but I have other terms I need to find as well. I want to find the next one, A3. To do that, I just repeat the pattern here. Add 3 to the previous one. And the previous one is now A2 because I'm focusing on finding position 3. I need to look at the previous one and add 3 to that. But I need to find the next one too. So I have a bunch of these. In order for me to find A4, I need to look at the previous one, A3, and add 3. So the same instructions, so to speak, continue. And I don't want to refer to a specific position when it's the same thing I'm doing infinitely many times, wherever I am, right early in the sequence or way later. What I'm going to do is the same. So to find a term which is in position n, whatever your position is that you want to look at, could be the second position, could be 100th position, doesn't matter. Look from somewhere in the sequence. Look at the previous term, which is in position n minus 1, and add 3 that. Now I'm not really attached to any specific position. And this single line is sufficient by just saying, well, if you want to look at position 2 for n, go right ahead. The same thing is going to happen with position 3, 4, as far as you want to go. So this is my translation of the exact same instructions or observation of the sequence, but I need two things. I need to know where to start, and I need to know how to go from one to the next. For example, now we're close to the end and we have to continue this discussion tomorrow, but that's often going to happen. My own example, not an exercise. If I say a1 is equal to 2, and to get a term, or I'll say it like this, an is an minus 1 plus 4, and that applies to all other positions. N is the position, right? Can I use this? Can I read this language to make the sequence? It's my sequence that I need to make, let's say 5 terms. Of course, it goes on forever. Now, what might help me might be to indicate the positions so I don't get confused. Maybe that helps me. It certainly does. Now, the first part here says the first term is a 2. Fill it in. It's done. It's not going to change. Because in this way of explaining a sequence, I need to know where to start. Now, the next line tells me how to go from there. So to find the second term, which will be named A2, this says, so for now, for my immediate purposes, n is equal to 2. The position I'm focusing on is a 2. So A2 is what I'm trying to find. It says use A1 and add 4. Ooh, that's an ugly 4, I apologize. And therefore, I'll get a 6. Now I'm done with that one. Now I'm moving on to position 3. Now n is 3, and I want to find A3. The instructions say use the one before and add 4. Well, the one before is 6, so I'm going to get a 10. And so I continue to get 14 and 18 and go as far as I want to go. So the very first thing that we need to be able to do is read something like this. Yes, we call it a formula, but it's really just instructions in the mathematical language. And in order for me to understand what it tells me to do, I need to be able to read the language. Now we'll stop here because that's as far as the first section got. We had some technical issues and we lost a few minutes, and I want to keep everything in sync. Are there any questions at this stage? We're not done. If you look at the book, there are more exercises and things to do. You never have to read ahead if you don't want to. We're just going to pick it up where we stop here tomorrow, and systematically we'll get to everything we need to get. But are there any questions or comments about this right now? It's just a reference. If I go to my previous page here, down a little bit. If I want to make general statements without knowing exactly what the sequence looks like, I'm using these A's to refer to different parts of the sequence, different terms in the sequence. Now each A, because they're all different, they have a subscript that corresponds to the position where they sit. Now if I look at the first few, sure, the positions start 1, 2, 3, 4, 5. But if I want to make a general statement, general instruction, I don't want to be attached to any specific sequence, any specific position. So I use an N because someone might want to find something in position 100. Then for their purposes, N is 100. And A sub 100 will refer to the number that sits in the 100th position. Regardless of where I am, if I'm looking at this window, now N is equal to 5. Trying to find that one, this instruction tells me look at the one before it one position less, which is this one, A4, and then add 3, which is exactly what we're doing. If my position is over here, or my window, and I'm trying to find that second term, well then, for my immediate purposes, n is equal to 2. 2 is the position I'm trying to find. The name of the number I want to find in that position is currently A2. I don't know what it is yet. The instructions tell me wherever you are, you're at 2 currently? Okay, n is 2 for you. Look at the one before, one position less, which would be this one, and add 3. But now this instruction is, if I look at the words, the instruction doesn't care where I am. I'm shifting my window systematically to make more numbers in the sequence. It doesn't care where I am. I have to decide where I am. So it's giving me a general instruction. Wherever your window is, early in the sequence, later in the sequence, wherever, do the same thing. To find a term in the sequence, look at one position less, so the one right before it, and add 3. But because the instructions don't know where I am in the sequence, and I'm going to shift my view anyway, it tries to give me a general instruction for how to calculate any term I want. And in this case, how I do it is by looking at the term that came right before it. See, position n could be anywhere, but relative to that position, I look at the position 1 less. So in that sense, my window can be wherever. It's always going to be relative to where I focus. Does that help? Sometimes, don't assume, oh, it's lesson 1. These things should be very obvious. No, a language is hard to learn. And if you haven't seen this aspect of the language yet, of course it's hard. You put another language in front of me and expect me to understand it, it's not going to happen. And it's going to be difficult to take those initial steps. It's no different. It is just a language issue. This is just maybe a more scary looking technical language, but the aspect of language learning is the same. And then a month from now, it happens every semester. A month, 2 months from now, you look back at this and think, oh, well, how did I ever struggle with this? Just like you would if you learned a new language. Those first lessons, and then a year later, you look back like, oh, those words were so easy. It's all a matter of where you are in the learning journey. So we go slow enough so that we can take our time and think about these things and get used to it and comfortable with the language aspect. If we rush through it, we need time sometimes. So luckily we have time. But if you have any other questions, send an email. Come to the open Q&A sessions. Ask in the session. You see we have lots of time. Is there anyone else who wants to say something right now? Yeah, I'm kind of stuck. I have to do them in sequence based on the instructions. I don't have a choice. Yeah. So, yeah, it's a good observation because I might not want that limitation. So tomorrow we'll talk about, okay, what other options do I have if I don't want to necessarily do find the terms one at a time. If I need to get to the 100th term, doing them one at a time is going to take a while. Is there maybe something that is a little bit more efficient depending on my purposes? Now, we only want to get used to the language, so this kind of formula is sufficient for that goal, but not for any goal. All right, let us pause there and continue this discussion tomorrow. Enjoy the rest of your day, and we'll talk then.